Alright, we're going to move into exponents now. Hopefully you're kind of familiar with them. We're going to go a little bit more into detail with them. Your notes are on page 20 for this, and I'll kind of go through those and add a few examples of my own. We are going to talk first about multiplying with exponents for bases that are alike. So if you have something like, it gives you the math terms of it. So it says a to the m times a to the n equals a to the m plus n. I like to personally look at it more in terms of how this actually applies to you. So in the example here, they have 8 to the 4th power times 8 to the 3rd power. And what I like to do is I like to actually break this down into what it actually means. So 8 to the 4th power actually means 8 times 8 times 8 times 8. And then 8 to the 3rd power means 8 times 8 times 8. So the easy way to do this is to just count them up. And we have 1, 2, 3, 4, 5, 6, 7. So your answer is 8 to the 7th power. Okay, well, the shortcut, rather than having to write out all those 8s, is just to look. And when you're multiplying something with the same base, the base is the 8 in this case, all you have to do is just add the exponents. So if I gave you the example of a to the 7th power times a to the 3rd power, instead of writing out all those a's, we know we have 7 a's on the left and we have 3 a's on the right, so we have a total of 7 plus 3, so it's a to the 10th power. Okay, pretty simple in that case. Alright, so multiplying, I know it sounds kind of weird, but when you're multiplying the exponents together with bases that are the same, all you have to do is add the exponents. So when you're multiplying, just add the exponents. Now, if multiplying is adding the exponents, dividing is going to be subtracting the exponents. So if we have a to the 7th power over a to the 3rd power, okay, and we wrote this out, you'd write a times a times a times a times a times a times a all over a times a times a, right? That's what it would look like. So if you were working this like a regular fraction, you just cancel those out. So 1, 2, 3 of them cancel out, and you're left with 4 a's, or a to the 4th power, right? Well, the shortcut, instead of doing all that, you just subtract a to the 7 minus 7 minus 3. See if I can not write all sloppy for you guys. A to the 7 minus 3, which is just a to the 4th power. Okay, so pretty simple concepts there with the multiplying and dividing. So remember, if you're multiplying or dividing by the same bases, all you do when multiplying, you add the exponents, and dividing, you subtract the exponents. Alright, so the next part we're looking at here is the different exponents. So here we have a base of 5 with a bunch of different exponents next to it, and we're just going to kind of look at what it looks like. So if you have 5 to the 3rd power, that just means 5 times 5 times 5. If you have 5 to the 2nd power, that means 5 times 5. If you have 5 to the 1st power, that's just 5. Okay, now anything to the 0 power is only 1. Okay, so there's nothing there, so you just put 1 in its place. That's what you're left with. Okay, now, when you have a negative exponent, okay, the way you get rid of a negative exponent is what you actually do. You can see here how our 5s have been slowly dwindling down, right? Well, what you do in this case is when you have a negative exponent, what you actually do is you flip it over. So you put 1 above it, and you put its exponent now on top, but you put the base that was there on the bottom of the fraction with the current exponent. Okay, hopefully that kind of makes sense there. But we'll keep going here. So 5 to the negative 2 power, you just flip it over, 1 over, and you got 5 to the 2nd power. So if we have 5 to the negative 3 power, hopefully you know this before me, be 1 over 5 to the third power. Okay, so when you're talking about exponents, okay, and you have negative exponents, the only thing you need to do is you need to flip it over as far as a fraction goes and put your negative exponent as positive in the lower part of the fraction. Now there might be some cases where I ask you to write the following exponents or show your answer with no negative exponents. So if I wrote a to the negative 4 power and I said please write this in only positive exponents or with no negative exponents, then you would write the answer as 1 over a to the 4th power. That would get rid of your negative exponent for you. Alright, so now we're going to go to raising a power to a power. Alright, so if you take a look here, we're given the example. It's on page 21, about midway down. It's giving you the example of 3 to the 2nd power raised to the 4th power. Okay, and so what you're doing here is you actually start with the outside exponent, and everything inside the parenthesis that outside exponent goes to. Okay, so again, the exponents only go to what it's exactly next to, and anything inside the parenthesis would then be considered that. So here we have 3 to the 2nd power to the 4th power. So that means we're going to do 4 of those 3 to the 2nd powers. So you should do 3 to the 2nd times 3 to the 2nd times 3 to the 2nd times 3 to the 2nd power. Alright, now if you follow the rules that we just did, right, we're multiplying like bases, and so all you need to do is you add up all of the exponents. So 3 to the 2, 4, 6, 8 power. Okay, now the shortcut is this. When you have a power raised to a power, all you have to do is multiply the numbers together. Okay, I know this is kind of a lot to memorize right now, okay, but hopefully you'll kind of, you can kind of practice breaking them down and see how it all works, okay? So, say we had 4 to the 3rd power, and then we had that to the 2nd power. Okay, so that means we would do 4 to the 3rd power times 4 to the 3rd power. Okay, and now if you wanted to break it down even further and really look at that, this means 4 times 4 times 4, and this one also means 4 times 4 times 4. So how many do we have altogether? We have 4 to the 6th power. Okay, and if you look at it, if you look at the 4 to the 3rd, so we look right here, we look at this one, 4 to the 3rd and 4 to the 3rd, well, how do you get from 3 and 3 to be 6? Okay, you add those two together. Okay, but if you look at the top, up here, 4 to the 3rd to the 2nd power, how do you get from a 3 and a 2 to equal 6? Well, you multiply those together. Okay, so there's your shortcut. If you have a power to a power, you multiply them together. If you have two powers multiplying together, you add them. I know it sounds kind of confusing, but you'll get the hang of it. Let's take a look at another example here. Say you have 7 to the 2nd power to the 9th power. Well, I don't want to write all those out, so I'm going to use the shortcut here. Okay, you have 7 to the 2 times 9, so this is going to give you 7 to the 18th power. Okay, 7 to the 2nd power 9 times is going to give you 18 total. Okay, there's a few examples there. You got x to the 5th, x to the 5th power to the 3rd. So this would be x to the 5th times x to the 5th times x to the 5th, or x to the 15th power. Okay. All right. The rule on page 22 is just there. It says a to the m to the n equals a to the n times m. That's basically the mathy way to say it. I like to stick to the numbers because it kind of makes more sense there. All right. Okay, so on page 22 of your notes, they're going to talk about here raising a product to a power. Well, if you think about a product means multiplying, right? So you have a times b raised to the n power. And so this is almost like distributing. Okay, except for here you're going to be distributing the power. So you're going to take the power and it goes to everything inside the parentheses. So your answer will be a to the n power times b to the n power. So everything gets the exponent. So let's say, for example, you had, here they have 2 to the x, 2x to the third power. Okay, and so basically what this means is you're going to break and you're going to put the 3 with both parts of it, right? So 2 is going to be to the third power, and x is going to be to the third power there for your answer. Okay, now watch the difference. If we don't have the parenthesis there, okay, if there's no parenthesis around the 2 and the x, the only thing that gets the exponent is only the variable, only what it's next to. So your answer in this case would just be 2x to the third power. The 2 would not get it without the parenthesis there. So you got to be very careful in those cases. Okay, now let's say, for instance, you have this one, 3x squared all to the third power. Okay, so this third power is now going to go to the 3 and it's going to go to the x squared. Okay, so you have 3 to the third, and then you also have x squared, and then you have that to the third power, right? Well, if you go back to what we just talked about, right, the easy way to do it is just to multiply those together. So you're going to have 3 to the third power and x to the sixth power. Okay, well, technically your most correct answer is to multiply that 3 to the third out. So 3 times 3 is 9, and then times 3 again is 27. So you'll have 27x to the sixth power. And there you go. So there's taking a power to a power and taking a product to a power. Alright, I know we're covering a lot here, but we're going to go ahead and try and get it all done. You can take your time, go back over anything you need to. The last part we're going to go over here is a quotient, which is a division problem, raised to a power. So here you have x squared over 4, all of that to the third power. Now it works the same way as with the product. Okay, so you're going to distribute the 3, but this time you're going to go to the top of the fraction and the bottom of the fraction. So you're going to have x squared to the third power on top, and you're going to have 4 to the third power on bottom, okay, as the denominator. So x squared to the third power is going to give you x to the sixth, 4 to the third power, okay, and if you multiply that out, right, x to the sixth is going to stay on top, and on bottom you're going to have 4 squared is 16, and another time that's 64. So there's your example of a quotient. Okay, we could do another one if you want really fast. Let's do x to the third power over 5 all to the third power. So again, the third goes there and it goes down there. So we have x to the third over 5 to the third. So x to the third is x to the ninth, and 5 to the third power is 125. Okay, so there's some try these at the bottom of page 22. Give those a shot, and I'll work them out with you. Okay, so hopefully you have taken a look at the try these at the bottom of page 22. I'm going to go ahead now and go through them all. There's a ton. There's also a few on the top of page 23, so lots to do here. I'm going to work my way through them all. Hopefully you've got them all right, and we'll kind of go from there. So start with the first one. 6 to the fourth times 6 to the seventh. Okay, all you do here is you add the exponents. So it's 6 to the 4 plus 7. I won't do this every time, but I want to show you originally. So you get 6 to the 11th. There's your answer. Okay, next one. H to the 5 plus negative 9. So we got a positive and a negative. Means you subtract the numbers actually. You end up with h to the negative 4. Okay, we're doing division now. So we got 3 to the 8th over 3 to the 2nd. Okay, so division, we said you're going to subtract, right? So all you have to do is you just subtract the 2 from the 8. So 3 to the 8 minus 2. So you end up with 3 to the 6th power. Now, a little trick to division, maybe I'll tell you more about it as we get to one that we have, but a little shortcut is to subtract it and put the answer in wherever the bigger exponent is, and I'll show you how that works in a problem or two. So let me flip over. Okay, so this next one, it says w to the 3 over w to the 5th. Okay, now one way you could do it is just like we did. So you could do w to the 3 minus 5, and you end up with w to the negative 2 power, right? Well, when you do that, then you have to make sure you put a positive exponent, so you got to flip it over, and you make it 1 over w to the 2nd power. Okay, now sticking with that method is probably the best idea, just staying like that. But if you wanted to take a shortcut, all you have to do is just subtract it in the place of the bigger exponent. So like cross out the top one here and subtract the 3 on the bottom, and then that gives you 1 over w squared. Okay, so just a little shortcut in case you wanted to try that out. If you don't want to do it that way, you want to go through the other steps, go right ahead, it's up to you. Okay, so anything to the 0 power is always 1. So 4 to the 0, 1. V to the 0, 1. Doesn't matter what it is. If it's to the 0 power, it's 1. So those are pretty simple. Now we have powers raised to a power. So 2 to the 3rd to the 4th power. Okay, so if you go back through your notes and you remember now, okay, when you have a power raised to a power, all you have to do is multiply the exponents. So it's 2 to the 3rd times 4. So you end up with 2 to the 12th power. Alright, it's that simple. Okay, let's keep on moving on. Alright, next one. 2x to the 6th all to the 14th power. Alright, so remember, now it's a product to a power. So we're going to bring that 14 in, it goes to the 2, and it goes to the x to the 6th. So we have 2 to the 14th, and then x to the 6 times 14. Okay, we multiply those together, we get 2 to the 14th, x, and then be 6 times 4 is 24, carry the 2, x to the 84. Hopefully I did my math right, I did that right there on the spot. Okay, next one, the same thing, it gets distributed to the top and the bottom again. So we got w to the 5th over 2 to the 5th. Now if you have something small like that too, you could go ahead and work it out. It doesn't totally matter. I'll let you know if I want you to do it every time or not. So just know that might happen to you. G to the 4th power over n to the 6th power all to the 4th power. So again, distributing the 4. So we have g to the 4 times 4 over n to the 6 times 4. So we got g to the 16 over n to the 24. Alright, we're doing pretty well. Got just 2 more. So now we're multiplying 2 different products together. So here what you do is you multiply the numbers. So we have, I'll underline them, so you got a 5 and a 7, and then we're going to multiply the variables as well. So 5 and 7 is 35, and then you do x to the 6 plus 4, because we're multiplying, so we got 35 x to the 10th power. Okay, and the last one, now we're doing division. Okay, so the easiest way actually when you have numbers in them is just treat it like a fraction. So I actually like to kind of divide it down there. Hopefully I did that okay. It did. So 4 over 12 is going to reduce, right? So divide them by 4. You got 1 over 3 is the number part. And then the other part, you got x over x to the 7th. Okay, now if you don't have an exponent, your exponent is 1, right? So don't forget that. Okay, and then to do that, you can just, like I was doing earlier, okay, cross out the smaller one and subtract its exponent and put it in the place of the bigger one. So on top we're left with 1, on bottom we have 3, and then x to the 7 minus 1 is x to the 6th. Alright, so that was kind of a tricky one. Might want to work a little bit more on that. You can ask in class. Let me do one more really fast just to make sure you know what you're doing here. So 6a to the 2nd over 12a to the 5th. Okay, so reduce your 6 and your 12. Okay, so 6 over 12 is 1 over 2. And then with the other part, cross out your a and subtract your exponent. Put it in the place of the bigger one. So on the bottom you got a, because it's on the bottom left, the other one crossed out, a to the third power. Okay, so your answer is 1 over 2a to the third. Alright, hopefully that all makes sense. If you have any questions, feel free to ask.